So was the model supposed to be good or bad from the homework? Because that was like really on the fence.
Weird. The computer cannot recognize my flash drive. So is this working? Is this part working?
It flashed.
Oh yeah. So maybe the front.
Yeah.
Both ports.
Ports are probably bad.
One still. It's fine. Right now.
I'm so sick. Oh man. So you're gonna have to commute down.
Yeah. It's gonna suck.
Are you excited about moving now?
I am. I'm excited for our new apartment. I think I need to be around like all the Asian people, which is so lame, but
Yeah, it's not. Is it like somewhere where you're moving? You know a lot of people there?
I have some friends that live like closer to that area. Actually, there's lots of people with them too. But like all our favorite restaurants are there.
Mhm.
So.
The okay, yeah. Let me see.
Yeah, I don't have anything either.
But when you should yeah, I can do it. Keep the mouse not working. Thank you.
So is your SEM2 set up similar to this, ma'am? 5 homeworks, project,
Yeah.
and presentation?
Yes, you're right. Yeah. Yes. Okay, so now yeah. Yeah, in PLC we have the slides, we have the mediation on file. Because today we're gonna okay, I'm sorry, yeah.
Do they really?
Yes.
That's
We ran
annoying.
it at like in less than a 6-minute practice.
Are you serious? It's
Yeah.
crazy.
He finished, I think like second in the feature. He was second overall. But mine was good. I
And
pushed
men's
really
are just
hard.
like overall.
Overall, like he crossed the finish line second. I had no
How'd you
idea.
do?
I crossed like 270th, but I did better. I did a good job for myself.
Yeah.
I pushed really hard. I feel it now. It's fun.
Yeah. Good job. Okay. flew in, but then I had my girls with me. I got the dates mixed up.
Oh, good. Oh, good. It was really cool.
So what you're sending me download from the file?
Yeah, okay, yeah, so please go to
My mom's a big
PLC
runner.
and we
Oh, yeah?
have,
Yeah, she ran a 100-mile race. which is like-
we have the slides and then the R file. So this is the mediation, because today we're gonna cover the mediation part and R file, the data for the R. And the M plus input file, again, for mediation and the data for M plus, for M plus. And the EQS file and also EQS data and the Amos file, which is for Amos. But yeah, unfortunately, we don't have the program, but if you have your laptop version, then please download the data and do the exercise. Yeah, and plus, it's also working here in this computer, which is good. Yes. Okay, so we are ready, and then let's move forward to the mediation. Okay. Okay, this is the last class. We have already talked about the model fit evaluation. We introduced several indexes, okay, including RMSEA and a lot of GFI, NFI, CFI, a lot of FI, and also a lot of like IC series, and we had a lot lab. Today we're gonna formally look at the mediation. Actually, mediation is not, it's not new for us. We have already done homework 1, we have already done homework 2. All of these are about mediation, but we never talk about the steps or how to do the analysis. So how to conduct a mediation analysis, we will go through 2 examples by using different software. Okay, and then, yeah, I will share all the code and the data and we have some, let me see. Yeah, we will have a simple example. We will also have a little bit more complicated example. Yeah. That's for our mediation. So this is our homework. For homework 1, we have 3 variables. We have W here, we have X here, we have Y here. And the W causes both X and Y. And X also causes Y. Okay, so you can see that actually there's an indirect path and there's a direct path. So combine indirect and the direct path together, we call it a mediation. This is a mediation model. And of course, we have a lot of assumptions. For example, the residual part. These 2 residuals are not correlated. And also, W, the independent variable, and the residual of Y is not correlated. And the W and the another dependent variable. Here we have 2 dependent variables. X and Y are all dependent variables. W and V are independent. Okay, so we have, and also these 2 are independent. X and E, yeah, X and E. And we also have a simplified model. This is a full path diagram. But sometimes we use simplified path, okay, path diagram. For example, in this case, we just ignore the V and E, but actually they are there. Just for simplified path diagram, we just ignore this part, but actually it's here. So that's why when we calculate the variance of Y, actually we calculate the variance of the residual of the Y, okay. When we try to calculate the M part, actually this is about the variance of the V part. So now we're gonna study this model. But before we look at this model, I'm gonna try to separate the 2 parts. Okay, SEM theory part and SEM application part. So I want to talk about theory in the very beginning, give you some foundations, some concepts, also some steps, and then we're gonna apply. We're gonna use different computer software to do the data analysis, apply this model to the real cases. Okay, so I will try to keep balance between these 2 parts. And for the theory part, I try to make it simple, but there's some statistical foundation involved. So if you have any question or if you cannot understand, you can just stop me, or you can just ignore the foundation part. Maybe that is the theory part. For quant students, it's more like a focus, but for non-quant students, maybe application is more important. Okay, so mediation, which is very popular actually in these days. So this is the citation. Actually, I should update this citation. There's a paper written by Barron and Kenny. Okay, did I upload that paper? Okay, I will do it during the break. We will talk about that paper. And over 30 years, it has been cited, okay, 15,000 times. And I should update that number again. So because now it's more than 30 years. So basically, mediation model is a causal model. I mentioned the causal model, causal inference model previously. Okay. So in this model, we are assumed, okay, it is assumed that we know which variable is cause, which variable is outcome. Okay, so which variable gonna cause some other variables. It's assumed that we know those relationship. Okay. So if that model is not correct, if the assumption is not correct, then the result from the mediation actually is of a later value, because if you reverse the logic, if you don't know which one is cause, which one is effect, then it's not necessary to draw mediation model. Okay. And there's actually statistically, so a lot of people don't think that the mediation is a stat model. So if you took a course from stat department, they will not cover this part, because actually this model is coming from the behavioral areas, and also it's not a statistical model. Okay.
So it's more human dimensions.
Exactly. So it's very widely. I cannot say that because some people also argue that it is a stats model, but actually originally, okay, or I can say that originally it's not treated as a stats model, but stat people also trying to investigate these cases. So let me give you some examples to apply this mediation model. For example, let's look at the first statement. Okay, the question: does physical abuse in early childhood lead to deviant processing of social information that leads to aggressive behavior? Let's look at this statement or question. Okay, we have three variables involved. The first variable is physical abuse in early childhood. That's one variable. And then we have a second variable, deviant processing of social information. And then we have third variable, aggressive behavior. So based on this statement, we clearly know which one is cause, which one is output or effect, so that we can draw the single-headed line among them. Okay, so we clearly know, we didn't say that, okay, there's an association between these two variables. We know that which one is cause, which one is the effect. So actually based on this one, so the first variable goes to the second variable, okay? And also the second variable goes to the third variable. And let's look at the second question. Do expectations start a self-fulfilling prophecy that affects behavior? Also, we have three variables involved. Okay, and we know that the cause and effect. And the third question, does trauma affects brainstem activation in a way that inhibits memory? Okay, so trauma gonna affect brainstem activation, okay, in some way that inhibit memory, so they have memory variable. And the fourth question, does secondary rehearsal increase image information, which increases word recall? Okay. So you can see that there's a train, there's a causal chain, or there's a reasoning train here. Okay. So to answer all of these research questions, we can definitely use a mediation model. Okay. Okay, so let's start from a very, very simple case. This is a simple linear regression. Okay, so we use it as our example in many, many cases. So X gonna influence Y. So that's why we have X and the single-headed goes to the Y. Okay, and we also have the variance of X. We have the variance of residual Y. This is the residual, okay, E of Y variance. And we have the C. C is the coefficient. And by written the mathematical form, we have Y equals C times X plus the E part. We have the variance assumption. We also have the variance of the E, sigma E here. That actually is called the total effect. Total effect, what does that mean? If I just focus on these two variables only, okay, X and Y, then if I get the C, that's a total effect from X to Y. When we don't consider a third variable. Now let's add a third variable into this model. We have N here. Then the total effect actually is divided into two parts. One part directly from X to Y. The other part is from M and then goes to Y. Okay, so in this case, we have three paths or three coefficients, A, B, and the C prime. Now I use C prime because the C prime is different than the previous C. In the previous case, I use C, which is a coefficient estimated by ignoring N. Now I have C prime. This is a different coefficient. If you can check, okay, the C and the C prime is different because we have some other part of the effect. So this is mediation model. And the M here is called a mediator, okay, mediator N variable. And based on that model, actually this is also not new because in order to finish homework 1, I already gave you these two equations. These two equations is our mediation model, okay? And this is mediator is caused by X. Look at the arrows. Okay, M is caused by X. So N is, of course, the coefficient is A times X plus the residual. Okay, this is simplified model. We have the residual E of M, residual of M. Okay. Of course, we assume that the center is mean part is 0. We didn't consider the intercept part. Now let's look at the other variable Y. Y here we have two arrows goes to Y. Okay, we have arrow from M. We also have arrow from X. So that's why here we have two independent variables. We have X and M. The coefficient from X is C prime. The coefficient from M is B. And we have the residual. We have the residual for the Y. Okay. And we have we have the assumption of variance part. Okay. That's a mathematical form of the mediation model shown above. So I mentioned that we have total effect. Let's talk some concepts. Okay, in mediation, we have different effects. We have total effect, we have direct effect, we have indirect effect. Okay, so in the first path diagram, if I show X and Y only without M, this C is called total effect. Total, okay. And if we add the mediator into this model, we have this whole mediation model. Then we have the C prime. C prime is called a direct effect. Direct effect, direct from X to Y. And here we have another path, from X to M to the Y, which is called indirect effect. Or in other words, it's called mediation effect. This is mediation effect. It is A times B. It's a product of two coefficients, A times B. So basically, if someone asks you, okay, if there's a mediation effect or not, it is going to test if this A times B is significant or not. We're gonna compare with this one, A times B with 0. If A times B is not 0, that means, okay, A times B is significantly different from 0. Then we say that, yes, there is a mediation effect. Otherwise, we say that, okay, M is not necessary here. Okay, mediation effect is not significant. Yeah, question.
So if you're looking for significance for the mediation for A times B,
Yes.
do you compare that to C prime?
No, compared with 0.
You compare it only with 0.
Yes,
Okay.
yeah. If it's significantly different from 0, it could be positive, it could be negative. I cannot say that if it's larger than 0, it could be, yeah, plus, it could be negative. But if it's significantly different from 0, we say that there's a mediation effect. So this is the focus. Okay, this is the focus, not C prime, not C.
Sure.
Yeah.
Thank you.
Okay, yeah, and sometimes it's also called indirect effect because it's indirect. It has to go to the mediator. Okay. Clear? Okay, good.
There is mine.
And there's a relationship among these three effects. The total effect, C, has to be the sum of the direct effect and the indirect effect. So C here is the sum of C prime plus A times B. That's the kind of like a rule of the mediation effect. Okay, so total effect should be, or definitely should be the sum of these two pairs. Okay, and by using the lab time, we will verify this part. We can run this model. Okay, we can run this model, and we can add these together. We will see that it's true. Okay. And here, actually, we have two cases. Inside of the mediation, we also have two cases. One is called a complete mediation. The other one is called a partial mediation. Complete and partial. How to define these two cases? Okay, so for complete mediation, the C prime is 0. When C prime is 0, okay, what does that mean? When C prime is 0, when this one is not a significant inference Y, so there's a no significant inference, then we can say that this is a complete mediation because it complete changes the path. Okay. So X no longer affects Y after M has been controlled. Okay. So this is called a complete. But we do have another case which is called a partial mediation. So the rest of the cases are partial. That means the C prime is not 0. Some part is explained by C prime, some part explained by A times B. Okay. So the path from X and Y only reduced, okay, reduced in absolute value, absolute size, but still different from 0 when the mediator is being controlled. So when C prime is not 0, then we call it partial. Good, okay. So if the research question just asks you if there's a mediation effect, you can only check this part. But in order to do more, if you want to investigate more about the mediation, it's partial or complete, then you're gonna investigate the C prime. Okay, C prime is not necessary for mediation. But if you want to know is it complete or partial, then you have to look at the C prime. Okay. That's a logic. So in order to do the test, it's very clear. Okay, we're gonna check if A times B is 0 or not. That's our null hypothesis. That's our X0 null hypothesis. Or in other words, we're gonna check if C and C prime is the same or not. Okay, C is a total effect. C prime is a direct effect. If these two are same or not. Okay, these two statements are exactly the same. And then we are going to test test if this is true, H0 is true or not. Okay, A times B is 0 or not. Let me see this. Okay, so let's go to Yeltsin. I'm gonna upload another paper here. Okay, the Barron's paper. So please go to Yeltsin and there's a one paper called Barron. Okay, and I'm gonna send you another one. Suppose test, suppose one. This is a paper I just cited, I just mentioned, okay, it is widely cited paper. It's first published in the Journal of Personality and Social Psychology, okay, in 1986. It's a moderator, mediator, variable distinguished in social psychological research, conceptual, strategic, and statistical considerations. Of course, we will cover moderation. After the topic of mediation, we're gonna look at moderation. And also we have a lot of combinations of these two. Moderated mediation or mediated moderation. Okay, so we have some combination, hybrid models. So the paper talk about moderation analysis first, okay, but we can go to mediation part. This is the mediation part. Mediator variables, and that is a model. Independent variable here, and we have mediator here, we have outcome here. So in this paper, I just summarized this paper for you. Okay, in this paper, it shows us different steps. Okay, so let's just go through these steps to see how Barron and Kenny address this research question. So first step, we're gonna look at the total effect, the C here. Okay, X goes to 1. So why is outcome variable in this step? In the first step, why is a criterion variable or outcome variable or dependent variable? So we have different names for Y. In a regression equation, and X here is an independent variable or predictor, and the C is estimated between these two. Okay, this is a coefficient. So actually this step tells us, okay, there is a relationship between X and Y. Okay, so the C is significant. Then we're gonna divide it into 2 parts. That's a goal of the first step. Later on, we will go back to this step. Okay, we will go back to see this step again. So let's look at the procedure of this paper. C is the first step. And then second step, we're gonna add an M into this model. And then we're trying to investigate the A coefficient. Okay, so A is a focus in the second step. So we want to see the independent variable X and the M has some correlation. Okay, it's correlated with this X and M. So M now it becomes a dependent variable. This is a dependent variable, and X is an independent variable. We just run, actually we only need to run this part. Although I show the whole mediation model here, but actually the focus is, it's just run the simple linear regression between these 2 variables. Okay. And then we check if A is significant or not.
Significant as above 0.05. Or it's
If
a
you
zero.
think alpha level is 0.05, yes. So if we're gonna check if this A is significant,
Yes,
Yeah.
ma'am.
that's a focus of this step, second
Okay.
two, step 2. And then in addition to A, we also need to look at B. Okay, B. But B, in order to look at B, you cannot just look at these two variables. You cannot run a simple linear regression between M and Y. That's a common sense. Okay, because this is a B, connect these two. Okay, I'm gonna investigate this simple linear regression. That's not correct because Y is also influenced by X. So we have to consider X into this model. So we have M and X together, and then
But you're skipping A. 'cause
skipping.
A,
Yeah, A is not here. Yeah, so
okay.
this is a model here.
Sorry, I'm just trying to follow.
Yes, you're right. Yeah, you're right. So in this case, in this step, Y is a dependent variable or criterion variable, and both X and M should be the independent variables. Okay. So actually, it's also it's just going to test this equation. It's going to test this equation. The first step tests the C. The second step tests A. A is going to use this model, this equation. Third step, going to test B. So because this is a whole equation, we cannot ignore the X part. So you have to include this part. Okay. You cannot just directly test the B here. So this is the equation.
But you're saying there also with the variance there to the side, is that getting tested as well? Or
No.
we're
This is
looking
just
at the top?
assumptions. This is just good notations.
Okay.
Yeah, we use these notations.
Sure.
Yeah, because this is for M, this is for Y, because we have two residuals,
Sure.
just notation. Yeah,
Thank you, ma'am.
yeah, thank you. Yes, yeah.
So then when you want to find A, you can do linear regression from X to M.
Yes.
To find A,
Yes,
but for B, you can't use a linear regression. for
no,
that coefficient.
no. You have to include X, you have to, because this actually is a multiple regression. M and the X gonna together influence Y. So that's why the B is estimated. If you just think about M and Y only without X, then the B is it's different as the B here. So you have to show it's within the mediation model. Yeah, if you take out X, the B will definitely be different. Yeah, so you have to consider in this scenario, in this case, yeah. So both X and M, yeah, both X and M are independent variables.
So how would you run that?
I will show you. I will show you the code. Okay, yeah, first part is just theory part. Let's just be very, very clear about the logic, about the
Yeah.
concept, and then we move forward to the example so we can understand each step. Yeah. And then we have a fourth step. Check C prime. Okay, check C prime to see if this direct effect is zero or not. Of course, equation to run this step is similar, the same equation as the third step, because the third step we run the multiple regression with M and X and that goes to Y. So third step we focus on B part. Now we're gonna focus on the C prime part. Okay. So step 3 and step 4 actually is using the same equation, the same it's actually the same step. Okay, but we have two tests, test B and test C prime, to see if M is a complete mediator or not. Okay, so this is our goal, to check C prime. Okay, that's it, 4 steps. Okay, first step, C, total effect. Second step, A, by running simple linear regression. Okay, third step and fourth step actually have the same equation. Third step check B. B is significance, and the fourth step is to check the C prime significance. Yeah, question.
If we have multiple mediators, does the steps change?
Exactly. So we will have the second example. So this is our first example. I will just start from the simple one. Next is more complicated. We have so many mediators. We have many mediators. We also have many independent variables involved. Yeah. Okay, so what's the conclusion based on that paper? So if we have 4 steps, okay, if all 4 of these steps are met, I said met, that means okay, significant, okay? Then the data are considered to be consistent with the hypothesis that the M, the mediator M, complete mediates the X to Y relationship. Okay, it's complete. If we only have 3, the first 3 steps met, okay, then we have the partial mediation model, okay, because the 4th step, check C prime, is to check if it's complete or partial mediation. Is that clear? So 4 steps, okay. But now we have a question. Are these all steps necessary or not? 4 steps. In order to answer the research question of mediation, do we need to test all these 4 steps? Is that necessary to run all these 4 steps?
Wouldn't it depend upon your model and depend upon the type of mediations?
Yes. Okay. So if we don't need to know if it's complete or partial, if I just want to know if there's a mediation effect, then the 4th step is totally necessary. It's not necessary. Yeah.
Right.
We can ignore the 4th step. But step 1, 2, 3, the 3 steps are all necessary or not?
Yes, because step 1 is going to be looking at
Total effect.
the total, and then you've got to add up to the others
Yeah.
pieces to equal the total effect. So you have to first identify your total effect,
Yeah.
then you're breaking it down
Yeah.
to ensure the others equal the
Yes.
total effect.
Yes.
So all 3 would be necessary.
But remember, our focus is A times B. If A times B is significant or not.
So if it's not significant, would we automatically stop?
Yeah, question.
Well, no, I was gonna say, dude.
Yeah.
To your question, then if A and B is significant, then we wouldn't even need to worry about 1, right? The total effect.
Exactly. Actually, okay, the first step is trying to test if the C is significant or not. Actually, this step is, you think about that, this step is not necessary.
Because it does have mediation.
Yeah. Actually, in some cases, we do have significant mediation or indirect effect. And also we have this effect, but the total effect, when you sum them together, it's not significant. Because these 2 may have canceled with each other. Some maybe have the plus and the minus. So if you ignore the M, if you just look at these 2 variables, in some cases, it may show there's no relationship or the coefficient is not significant. So it seems that X is not influenced Y because the coefficient is so weak, it's not significant. But actually, when you add M into this model, you can clearly know that, okay, there's a strong relationship between X. And of course, we have some other part canceled with the mediation. So the first step is not necessary. You can just directly run the second step, okay? And the 3rd step to check if A is significant, B is significant, that's it. So this is our goal. Okay. So for step 4, it's not necessary unless you want to look at the complete mediation or partial mediation. And also step 1 is not necessary, it's not required. Yeah, so if we have C prime and A times B has different signs, sometimes, for example, this is a positive, this is negative, or sometimes this is positive, this is negative. It's possible. And then these two patterns, these 2 effects just cancel with each other. Then we still have the non-significant C, the total effect. In that case, In this case, it's a very special case. The mediator, also called the suppressor variable. Okay. It's a suppressor variable. So the key steps are 2 and 3. 2 and 3. For step 2, we check A. For step 3, we check B. Okay, B A times B. That's it. That's one way. Actually, that paper just gives us one way. It separated these two coefficients, okay, A and B, to make sure both of them are significant. And then we have the product. But actually, we have another way. We can just direct test as A and B times C. For variance paper, we have 2 steps. And for A, gonna test, B gonna test. We have 2 tests, but we can also test A times B at the same time. Okay, single test to see if it's 0 or not. And this method has been proposed, was proposed by Sobel, okay, in 1982. Okay, it's called the Sobel test. Actually, it's earlier than variance paper, but this paper is shown in a statistical way. Okay, it's not a quite popular read by the person in the psychological areas. So it's called the Sobel test. And I also uploaded the paper to ELC. Asymptotic confidence interval for indirect effects and structural deviation models. Okay. We start from the SEM theory. Okay. And they also derived the asymptotic distribution. Okay. And he also trying to use a delta method. We will cover this part, the delta method, to try to look at the function of the asymptotic distribution. Now we have the example. So for in the paper, the Sobel test actually trying to provide the standard error of A times B, because the final goal, let's look at the test mediation. What we want is to try to look at this product, if it's 0 or not. That's our goal. So in variance paper, so they trying to test if this one is 0 or is this one is 0, and to make sure the product is significant or not. But in the Sobel's test, we just do the single test the A times B, and then using the t-test, okay, the variance of the standard error of A times B, and then check this ratio, do the test at the same time, okay, in one step. So standard error of A times B is not easy. This part is not easy. So that's why we use a asymptotic distribution to show that we have the asymptotic variance. In the square root, we have the standard deviation. Okay, so this is estimate or approximate. It's not exactly the standard error part. It's a approximation of the standard error of A times B. A is a coefficient of that part. Okay, SB is a variance of the coefficient of B, and we have the B, okay, times the variance part of the A, because for A and B we also have the variance and the standard errors part. So asymptotically, we assume asymptotic means, okay, it's not exactly the same. When the sample size goes positive infinity, then we have that distribution. Okay, So asymptotically, this ratio, the standard error is here. This is the standard error. So standard error here, A times B. This ratio approximately like a distributed like a normal distribution. So we can use a z value to do the test. Okay, by using this ratio and the test compare with z value. Okay, this is a theory. Okay. So the theory behind, I'm sorry, of this paper also is based on a delta method. Okay. Suppose we have B is a vector of parameters. Okay, it's a multivariate. Okay, we have vector part. Suppose it has a symptotic distribution like normal, and the beta is the point estimate of the beta, the B here, and we have the covariance matrix capital sigma here. Then, based on the delta method, any function of the vector of B here, H we assume this is a function. Okay, the function, some function of this B also have a symptotic normal distribution. But the mean part, okay, the standard part, the point estimate part becomes a function of that, the beta, the estimate of the B. And we should use a delta method to derive the covariance matrix here. Okay, so the original covariance matrix is here, but we have the first derivative of the function with respect to each parameters here. Okay, this is a vector. And this is a transpose. Okay, we're gonna do the first derivative with respect to each parameter again. So that is the covariance matrix of the function of the B. So this is called the delta method. So the paper trying to apply this method to the mediation, and they trying to get the result. Okay. So let's look at the paper again. We also have the examples. Now the f function, the first derivative of the f function, with respect to the, here they use delta. Okay, delta is the parameters. Yeah, so this is kind of like a matrix. And then we also have the very simple case. Okay. In the paper, they use a B times C, but in our slides, we use A times B. Okay, but the same thing. Okay, so it's the same thing. This is a B times C based on limited sample size AN here, but this is a point estimate of symptotic. Okay, B times C. So the estimate of B and C. And here, this is a variance of variance 1, covariance 1, 2, variance 2, 2. So they did, in our slides, we use a capital sigma here, but we have a detailed form if we have 2 by 2 matrix. So assume that we have the capital sigma like this way. We have sigma 1, 1, sigma 1, 2, sigma 2, 2. Okay, this is a capital sigma, and all the elements can be derived here. Okay. Sigma 1, 1 here. If you use a variance A and B, so again, the notation is kind of like different in our case. If we here we use BC, in our case we use AB. So if we again replace the BC with our AB, then this is the variance of A, this is the variance of B, this is the covariance between A and B. So here we have variance of here this we have variance of A, but C becomes B. Okay, so yeah, it's B squared times the variance of A, and then times 2BC. So if we use a symbol in our slides, it's 2 times AB, covariance between A and B plus, okay, B becomes A times the variance of B. Okay, here we assume this is a variance of B. Then B becomes A. So A squared times the variance of B. Okay. So anyway, this is the difference between the two sets of notations. But the formula is here. So in many cases, we assume that A and B are independent. So that's why. So the covariance here, covariance 1, 2, is assumed to be 0. So if we ignore this part, if we ignore the sigma 1, 2, which is the covariance between A and B or B and C 0, then we have the slide. We have this variance. Okay, we have this variance, 2 parts. And of course, if you want to calculate the standard error, you have to take the square root of that variance. There's something. Again, I just trying to talk about the theory part, and we have our package to run all of these for us. So the theory is here, and after we install that package, automatically it just show you, okay, what is your indirect effect, what is your direct effect, what is your mediation effect. So it's very convenient. And
Is
you have
that
to-
still the SEM package?
It's related, not the same as SEM, but it's gonna use the SEM package. Yeah, it's called another package. Yeah, yeah, I will use the code. And yeah, so that's a theory part. That's a theoretical part about mediation. Basically, we have 2 ways. You can just run it separately by test A and by test B. The other way, simple test, just run it together. Okay, A times B together. Okay. And then we're gonna check the standard error of A times B. Any question so far?
What is-
Good.
What
Yeah,
is the
question.
name of the package that you were
Oh,
referencing for the SOBI test?
Package is just a collection of bunch of functions. Package in R. So there are a lot of package in R. SEM is one of them. Yeah.
Right,
yeah.
right. But to run the SOBI test that you were just referencing, what package do we use?
BREM, yeah, we're gonna use that one. Yeah,
Okay.
yeah. Okay, so if we don't have any question, let's move the first example to another example. Okay. Okay, this one is still the simple one. I'm sorry, this is still a simple case. After we run this, we will talk about another example. So the first example, we use the same data set. We use it many times. We have National Longitudinal Survey of Youth, okay, 1979. So sample size 371, and we have ME, HE, math, mothers education, home environment, and the kids math achievement. So this is a hypothesis. Okay, we're gonna test whether home environment is a mediator. Okay, home environment HE, we're gonna test if HE is a mediator in the relationship between mother's education and the children's mathematical achievement. So mother's education is an independent variable. Mother's education gonna influence the kids' achievement. But we're gonna test if home environment is a mediator. That's our model. So this is our model. mother's education level gonna influence the kids' home environment. The home environment gonna influence the kids' math achievement, and of course, mother's education level gonna influence kids' math achievement. So this is our model to be tested. And we have coefficient A, B, and C prime, and of course we have the variance part. And we're gonna cover 4, software to do the test. And let's look at R first. Okay. R, as I mentioned, we have our package called the BMEM. So the first step, we're gonna install that package and then use library to make it available for us. So inside that package, there's a function called bmem.solve test. Okay, just run the solve test for us. Test A and B together. Okay. So let me see. We still have some time. So let's just move forward, move to R, so R Studio. If you go to R Studio. And please download the R code from PLC. Okay. So save those files and data into a local folder and change the session to your local folder. Set working directly to that one. And open that file, open file. It's called a mediation. Mediation.r. Mediation.r. Okay, let's just make this font very big. Yeah, first step, you need to install the package. So here we can just, click the package in the red panel and click install. And then have the name. Okay. And install that package. And then use library to make it active. Active is good. And we can also install the SEM. I think SEM, let me see, SEM is still not. Because we're gonna run the simple linear regression to check the total effect. In that case, we can just use the SEM package. So SEM is not installed in this computer, so I would just read it.
There it is. It's just not checked.
Oh yeah, here it's already installed. Yeah, okay. Then I don't need to install it. I just use library check. I'm checking that. Okay, these two packages are available for us. And of course, you're gonna set your working directory to your own folder. And after you download the data, which is called our data.txt, then save it to your local folder. Then we can use read table to import that folder to R, make it ready. So we call it data set, dset. Oh, dset is not available. Okay. Our data maybe is not here. I haven't changed that session. Now it's ready. Okay. And the first step, I didn't do the change directly, so there's some errors. It's our old data set. Okay, we have already used the exercise based on this data set. We have already done many times. Okay, so now the question is how to translate the test diagram into SEM code. This is our test diagram. This is our model to be tested. We're gonna translate this model into the R language, the syntax, okay, the code in R. So let's check A. So we're gonna estimate the parameter A. A is from mother's education to home environment. So ME goes to HE. The path is called A and starting value on A. B, okay, we're gonna estimate the coefficient B. B is a coefficient from HE to math. Okay, this path, starting value 0 on A. Okay. And then we also have the third path coefficient C prime from ME to math. So I call it C prime from ME to math and starting value on A. And we have the variance part, variance of mother's education, S1, we call it S1. And variance of the HE and the variance of the residual math, okay, so S3. And the Parmesan. That's our model, M1 of the model here. Question for the code in R. Any question for the code? Oh, for the homework 3, I have already finished grading the homework 3, so but I don't have the homework ready. So next time I will give it to you. Most of you did a really good job, but in M+, remember that in M+, we have some code, some command, just put those names, for example, ME, HE. The meaning is to calculate the variance, to provide the variance of those variables. Some students just said, okay, the meaning of that statement is, there's some different answers. Some of them said, okay, it's missing data of that variable, which is not correct. Some answered that that is a variable inside of the model, which is also not correct. Some said it's a latent variable, which is not correct. If you just put a name in M+, that means, okay, it's a variance, the variance of that variable. If you're trying to look at the mean, we use a bracket. Okay, some also answered that it's gonna provide the mean of those variables, which is not correct. Okay, if you want to look at the mean part, then you use brackets to show that. So that's for homework 3. So we will look at homework 3 next time. That's but for our part, let me think. For our part, most of you did a really good job. Except some students. Some students didn't explain the A part. Yeah, the 3 components.
Yeah, we're not going to stress that at all.
Okay, anyway, so any question for the model here?
I have a question, just like, why is it M1? Is that like a specific thing or is that just what you're calling the
S1,
model?
you mean S1?
No, just M1 at the beginning.
Oh, it's just a name.
It's just a name.
Name.
Okay.
You can
That's
call
what
it
I was-
mediation. You
Right.
can call it
okay.
my mediation, or you can call the mediation example 1. Yeah, it just
Okay.
yeah, it just name. It just totally
If,
yeah,
if you
random
look
name.
further ahead in the slide, she goes model 1, model 2.
Yeah.
It's
It's
for
just
the different
random name.
examples.
Yeah, examples. Because I have to use a name, I have to use a
Right.
model somewhere, so I have to give a name. Okay, yeah,
Mhm.
okay.
Okay.
So that's the model. Then we're gonna run the analysis, mediation analysis. So I said we're gonna use a function of sample test. This is a function inside the package. Okay, the function here. The data set is ready. So data set is provided here. This is our data set. Our data, save it as this set, data set. And then we're gonna provide the model. This is M1, the model name here. And then let's look at the third component here, indirect. What is indirect here? This is a definition. This is assignment of indirect. I'm gonna look at the A times B. This is a indirect effect. And I assign this value to the name of this is a variable name indirect, and I'm gonna check the estimate of A times B. So the results will be saved to M1 model 1 result. Okay, this is again this is object. A lot of results will be saved here. And then you can use summary to look at the result, especially you can use SEM. So there are a lot of names. You can use names of these objects. So they will give you all the results. So inside that results, we have a function, we have a variable name called SEM. So you can use $sign to take out that one and look at the summary. That's one possible way. Okay, that's one way to do that. And you can also change. You can also change the third component. For example, in addition to A times B, I also want to look at the sum of the indirect effect A times B and C prime. This is a total effect. Okay. I also want to check this part. It's okay. You can just add these names here. And the effects, we call it effects, and then put it in the third part. So after you run the package, it will just give you all the components analysis here. Okay. And then we use summary to look at the output of the SEM component. Okay. So let's go to R Studio. So we have already made the data set ready, so we can just run the M1. Again, try to highlight, include all of these blocks. Okay, so all of these lines together, including the pound sign. And click run or control enter. So we have our model ready. And then trying to look at the A times B, the indirect effect. So data set is ready, M1 is ready. Indirect is the A times B here is defined here. So we can just try to, yeah, let's try to run these two first. Okay. It gives you a very simple table here. Okay. Estimate, standard error, z-scores, p-values. Let's try to look at the names of one. We have estimates, we have SEM, we have two objects. If we just focus on SEM, then let's try to run summary. Okay. And the summary, this is the output of the SEM part. Look at the summary part. Again, in the beginning part, we have chi-square value of this model, degrees freedom. Yeah, degrees freedom. Y is 0. How many parameters in our mediation model?
So if we check, okay, let's go back to the slides. So here, how many parameters in this model? 6, yeah. 1, 2, 3. And we have 3 various parts, 3 coefficients. Actually, all of these 6 are clearly indicated here, okay, specified here. And the 3 variables. What is the number of information? 3 variables. P equals 3. What is the number of information?
It's gonna equal the same number as what we've got.
Yeah, so which
So-
number?
It'd be the 6.
Yes, yeah, P times 4 divided by 2. Okay, 12 divided by 2 is 6. So 6 minus 6, we don't have any actual degree freedom available. So we have degree freedom 0. And the AIC, PIC value, normal residuals, and that's the result, parameter estimate. We have a estimate, we have a parameter estimate, standard errors, value, p value, and this is the mean. Just like SEM package, okay, so the interpretation of this table is quite clear for us because we have the SEM package again, and the B coefficient here, B, and the C prime, okay, C prime here. This is too large. Let me make it a little bit small so that we can just see all information in one table here. So let me make it a little bit small. Let me try to. Okay, that's better. So in this case, so we have A coefficient, B coefficient, C prime coefficient, S1, S2, S3. Okay, S1, S2, S3 are variance part. Now we're gonna test the A times B, okay? So A times B. After we run the Sobel test, so the table including in times B, indirect effect, has been provided. Estimate of the product of A times B, mediation effect is provided here. Standard error of the A times B provided here. Z-score, okay, Z-score is a ratio of these two, estimated divided by the standard error, and the p-value provided here. If the alpha level is 0.05, please let me know if this is a mediation model. Is there any mediation effect in this model? Just based on the table here. Why?
8 times 8 is
Yes. Yes, you're right. Yeah. And now let me ask you, if the mediator home environment is a complete mediator or partial mediator based on this table.
complete
Why?
because your C prime is significant.
C prime is significant.
And
Then-
so is AB. And so that makes it all, it satisfies all 4 of our
Is it complete or partial?
complete. Partial. Partial? I thought it was both.
Okay.
They have to be equal.
Oh, dude.
It's
Like the
significantly
C
different from 0. It's not 0. So that means it's
Right.
not, it's significantly different from 0.
Right.
C prime is not 0.
Right.
So the mediation is partial or complete?
Partial.
Yes, partial.
Okay.
It just, yeah, it just tell us, okay, only part of the mediation, only part of the total effects has been divided, decomposed to the other parts, yeah. But the C prime, the direct effect is still significant. So if you go back to the slides, where is it? Yeah. So if C prime is 0, that means it's complete mediation. If it's not 0, then we have the partial
mediation. Yeah. So what does that mean? How to explain that case if we have so that means it is a significant indirect effect. So mother's education indeed, okay, significantly mediated by ME, and ME causes case method treatment. It is significant. Also, mother's education significantly influence the method treatment. Both of these are significant. This is important also. Mother's education also directly significantly influence method, kids method treatment. Both of these are significant. Okay, so this is a partial mediation, not a complete. Yeah. What time is it now? We can have a break. We can have a break, and we're gonna test this part. This is what is this? This is the sum of indirect effect and the direct effect. This is actually the C. This is a total effect. We're gonna verify if the total effect is a total effect without M or not. So next session, we're gonna run this part, and we also run the simple linear regression from X to Y without M, and to check if the sum is the same sum of the total effect. Okay. Okay, so let's have a break for 15 minutes, and we're gonna come back around 7:02. Okay, let's continue. So last class we just run a mediation model with a very simple example like this. And we have already looked at the subtle test of A times B. Okay. That's our output. Okay, so we can tell, but based on this table, this is a really important table. So if you want to do your course project or thesis or any other project research paper, you're definitely gonna include this table. Okay, especially show the last row. Okay, the last line, A times B. The estimate is here, the standard error is here, z-score is here, the p-value here. And based on this p-value, if the alpha is 0.05, then it is significant. It's less than 0.05. So there's a mediation effect. And by looking at the C prime here, estimate the standard error, z-score, p-value, it is also significant. So that means the direct effect is also significant. So A times B is a partial mediation in this case. And let's try to look at the total effect. So let's try to run this part. In addition to A times B there, I'm also gonna check the total effect, which is the sum of A times B and C prime. Okay, and you can just try to highlight this part and run. That's a table. Okay, that's a table. In addition to A times B, we also have the sum of indirect effect and the direct effect, which is total effect. So the estimated here, the standard error, z-score, p-value, which is very, very small. Okay, it is significant because it's in -5, so it's very small. Now let's check if this total score is true total score. Okay, oh no, I'm sorry, not total score, total effect. Yeah, this is our output. So, and also we have the if you want to look at the model fit information, then you can use summary. The summary of the SEM. In addition to this table, they also provide you the other related model fit information. Okay, so that is a table, estimated table. So now let's check the total effect. Without n, we're gonna see the inference from ME, mother's education to kids medical treatment. That's it. This is our model. In order to run this path diagram, so we have the specified model like this. Okay, we have the specified model like ME goes to math, which is C, the total effect. Also various part, various of ME part, various of the residual of the math part S3, and pound sign. That's a simple linear regression model. So let's try to run by using SEM. Okay, by using SEM, the model here, model for the total effect, and S is the covariance matrix. Covariance matrix generated or calculated by COV, covariance between of the data set. Sample size here, and let's do the summary. Okay, so go to R Studio and check the total. The next part is check the total effect. You can just highlight. You can just highlight the whole block here and click run. That's it. This is our result. This is our result for total effect. Okay. Again, the degrees freedom is 0 because in this case, we only have two variables. We only have x and y without n. So 2, when p equals 2, we can estimate at most 3 parameters. Okay, 2 times 3 divided by 2. We have number of pieces of information. Number of information is 3. And in this model, we have 3 parameters. We have C coefficient, we have variance of S1, we have variance of residual of S3. So we have 3 parameters. So 3 minus 3, the degrees freedom is 0. Okay. So that's why the degrees freedom is 0 here. And let's look at the parameter estimate. Okay, C estimated here. Estimate the standard error Z value, T value. Let's look at the C value. 52750. Okay, so if you go back to the previous model, when we get the sum of these two, okay, 52750. Okay, if you do the comparison, they are the same numbers. Okay, so it is true that the total effect is a sum of indirect effect and direct effect. So indirect effect and direct effect, the sum of this is a total effect. See here. Okay, so we just verified these two numbers. Yeah, this number.
So if you're using this for publication or any type of dissertation work, would you run those separately and write that conclusion in there?
For publication, you don't need to run the total effect.
Okay.
Here, I just want to do the demonstration that conclusion is true.
Okay.
Total effect is the sum of these two parts, but for articles, no,
Okay.
not necessary. You only needed to report this table.
Okay, thank you, ma'am.
Yeah, mediation table. Yeah, mediation. Even this part is not necessary. Okay, this part is just for our goal to do the verification. Okay. Yeah. This where is it? This is enough. This table is enough. Yeah.
Thank you.
Yeah. Okay. Yeah, so I just copied the results from our output. Okay. It's the same number. Okay. The same number. Where is it? It's here. Yeah, this is a number here. And this is the number here. So, any question for our part? That's it. That's for our part. Any question? We have already answered that question. There is a significant mediation effect, and it is partial. No question. Let's look at M plus. Okay, so M plus. This is the code. But still, we needed to use these blocks, the different blocks. So we have title, we have data, the data. This is a for M plus, we don't have any title. Okay, so the format is a little bit different. So that's why I call it M plus data. For the previous case, I use R data. R data, we have the header, FG, ME, math. But for M plus data, you can just open the M plus data to see. Okay, so M plus. Yeah, that's it. This is our data. We don't have any the first column name. We don't have the first row for column names. But here and the variables, you should give the names of all columns inside of that data set. So in that data set, we have 3 columns in total, MEHE math, and we are going to use all of these. Because there's no missing data, I just escape the middle statement of the missing. Because if it's complete, you don't need to specify any missing value indicator. So use variables. I'm gonna use all of these variables. That's it. And the model, okay, here, model, we have 2 equations. Remember, mediation, we have 2 regression models. The order doesn't matter. You can just start from this one, and then the second statement about that, it doesn't matter. So HE depends on ME. So that means model's education gonna influence home environment. Okay, so let me just copy this diagram here. Yeah, that's better. So based on this model, this is the first equation. So based on this relationship, HE is regressed on ME. So this is the first statement. And we do have another statement about math. Math is regressed on 2 independent variables. So math regressed on HE and ME. That's our model, 2 equations. That's it. Okay. But in M+, in order to get the report of indirect effect, direct effect, and total effect, so you should use a statement of model indirect. This is a key part for mediation. Without this, it will not report the mediation effect for you. So model indirect, math, IND, ME. What is IND? Indirect effect. Okay. There are some other keywords. There are some keywords like IND, VIA, VIA, or indirect. So we have some examples. So anyway, this is a M+ code, and you have to include the statement of model indirect. Okay. And the math indirect. I mean, so let's just look at this statement. What does that mean? Model indirect is a statement to report the mediation effect, and also we have the standard error report reported. There are 2 keywords to connect the 2 variables or more than 2 variables. We have IND and the VIA. So if you use IND, indirect effect, we can request a specific indirect effect for a set of indirect effects. Without, if there's no mediators, then all the indirect effects will be reported from the second variable to the first variable. Okay. So in this case, all the indirect effect from ME to math will be reported. But if you have some mediators included, for example, in this case here, in addition to HEPT, we also have these variables. These are actual mediators. So if you have this statement, that means EPT is a dependent variable here. This is an independent variable. These are mediators from here to here. And all the mediation effect from these 2 variables will be reported. But if you didn't report the mediators, If you just use an independent variable and the dependent variable, then all the paths will be reported. This is a specific, this is a specific indirect effect, specific indirect effect. This is all indirect effect, specifically from H to HBLTT1 to WS1 to EPT1. Okay. And if you use VRA option, it's quite the same. So this is a dependent variable EPT1, okay, and the VR, and we have H independent variable, we have the mediator here, we have the specific mediator here. So all the mediator, all the indirect effects will be reported if that will through the WS1, okay. So we have different options. Now, this is a specific explanation of IND. I copied it from the M+ menu, the code. Okay, the explanation of the code. So the variable on the left side of IND is a dependent variable. Okay, for example, in this case, these are dependent variables P1. And the last variable on the right side of the IND is an independent variable. Okay, this is an independent variable H. And between them, there are mediators. So other variables on the right-hand side of the IND are mediating variables or mediators. Okay. If in some cases there's no mediators, for example, in this case, there's no mediators. If there's no mediating variables including the IND options, then all possible indirect effects from the independent variable to the dependent variable will be reported. Okay, will be computed. And they will also report the total indirect effect. In our simple case, we only have one indirect effect, but in many cases, you may have a lot of indirect effect. You can have this one, you can have that one, you have a lot of paths there. The M+ will also report the total indirect effect, which is the sum of all indirect effects. And then it will report the total effect, which is the sum of total indirect effect and the direct effect, which is total effect. Okay, total effect is sum of total indirect effect and the direct effect. For VIA, yeah, it's quite similar as IMD. So the left side, the left-hand side of the VIA is a dependent variable. The right-hand side of the VIA is an independent variable, which is the last variable. And between these two variables are mediators, mediating variables. So all indirect effects from independent variable to dependent variable, and including the mediators will be computed. Okay. So that's a statement of this model indirect. And we have some examples. For example, for the first example, we have dependent variable, we have independent variable, but there's no mediators. So all indirect effects from H to EPT1 will be reported. But for the second example, is a specific path, okay, from H to HBLTT1 to WS1 to EPT1. And for VRAs, all the mediation effects from H to WS1 to EPT1 will be reported. So let's go to the M+. Open the M+ in your computer. And suppose you have already downloaded the code from VLC. It's called mediation.imp. Okay, input file in mediation in M+. Download that one and save it to your folder, and then just open that file. Okay, so that's a file. And you can try, yeah, to understand the statements here, and if you don't see any problem, there any. Oh, here, you know what? I also add a statement here, ME, just negate the value here. Actually, I want to report is a variance of the ME. And the model indirect. So when everything is ready, then you can click the run here, the red button run here. So that's a report, that's a result. Okay, so the beginning part is okay, the title, there's a repeat, the repeat of the input file here. And then a report is a number of groups, which is 1, sample size 371, number of dependent variables. Here, let's look at this case. Okay, in the previous SEM, we run multiple regression. The number of dependent variables is only 1, but here we have 2. Number of dependent variables 2, because it's a mediation model. We have math. We also have the HE. Okay, 2 dependent variables. Number of independent variables 1. We only have ME, mother's education, 1 independent variable. And number of continuous latent variables, no, we haven't introduced a latent variable in this case. Okay, so 0. Observe the dependent variables, there are 2, okay, HE and math, which are continuous. Observe the independent variable ME, okay. And the algorithm part, estimator, maximum likelihood estimation information matrix, observe the maximum number of iterations, convergence criterion. And yeah, so the convergence criterion and the maximum number of space that descendant iterations, input a file here, and data format, and summary of data. We don't have any missing data here. So we have the proportions. So all of these variables, 100% of all of these 3 columns are included. And we also have sample statistics. Okay, so sample size for each variable, mean for each variable, variance for each variable, skewness, catastrophes, minimal, maximum, percentage, and the median, okay, percentile. And then this is a good sign. The model estimation terminated normally. This is a really good sign. So we don't need to worry about the result is trustable or not. The first is a model fit information. Not likely to the value, criteria, the chi-square value, RMSEA, the CFI, PLI, and so on. Now let's look at model result. This is the estimate from our mediation model. Coefficient. That regress on ME and HE. So actually math on ME, let me think. Math on ME, this is A, this is A test. Math on, no, this is a C prime. I think this is math on ME, yeah, this is C prime, this is a C prime. Math on HE, this is a B, this is a coefficient B. And HE on ME, this is A, this is A path, estimate of A, estimate of B, math on ME, which is C prime, yeah, C prime, standard error, C value, P value. And yeah, you can ignore the mean part first. And variance, okay, variance of ME here, residual variance, variance of the residual of HE, variance of the residual math. Okay, all of these are recorded here. Now, let's look at the key part of M plus for mediation. The next part, after the model results, let's look at this part. Total indirect, specific indirect, and the direct effects. So all the model, mediation model results will be reported in this part. Let's look at the first part, total effect. Total effect from ME to math. ME is an independent variable, okay? And the math is a dependent variable. From ME to math, the total effect is reported by this number. It is true because we just verified. We just verified the total effect by using the single linear regression and also the sum of direct effect and the indirect. So we just verified in R. We calculated it in R. This is the total effect. Standard error, Z value, P value. Also, they reported the total indirect. And then after total indirect, we have specific indirect. 1, 2, 3. Actually, this is a really simple case. We only have one indirect effect, which is A times B. So that's why we only have one specific indirect. And these two numbers, okay, let's look at these two numbers are exactly the same. This number and this number, because we only have one path. But next example will be much complicated than this one. The total indirect will be the sum of all the specific indirect effects. Okay, and there's specific indirect 1, specific indirect 2. So we could have many indirect effects, mediation effects. And the sum of all of these will be that number, okay, will be this number, total indirect. And of course, we have direct effect from ME to math. This is C prime, okay, direct effect. This is C prime. And all of these actually is reported in the previous table, okay. 4.463, if you go up here, that's a C prime, okay. This is a C prime, the direct effect from ME to math. And this is A path, this is a B path. And A times B, okay, A times B is reported here. This is A times B, the total, not total, specific indirect, and also the total indirect effect. And we have the standard errors. We have the zero. That's it. And the other part is for the time, okay, the information on the company. Any questions for this part? So again, based on the result here, could you please let me know? Of course, the question, yeah, has been answered. So is there a significant result? Is there a significant mediation or not? But which number should we focus? Which number? Which is a mediation effect? Which number is the estimate of the mediation effect? Yeah, that one. The standard error here, the z value here. This is a p value. Okay. So if the alpha level is 0.05, so this one is less than 0.05, so it is significant. So this indirect, specific, or total is significant. Okay.
So M plus doesn't do like what R does, an asterisk beside the significant values.
Oh, this is more complicated. Actually, this is better because in the R part, we have to specify that part A times B. And but here we just report all of this for us directly. Yeah, yeah. Especially for complicated models, you don't need to specify okay which one goes which one. Yeah. Question for the N plus. Now let's go to the slides here. Yeah, model fit information here, results here, and the mediation effects here. Okay. If no question, then let's move forward to EQS. Okay, EQS quite similar as M plus, but we needed to rename it. Okay, we needed to rename these three variables into V1, V2, V3. The first part, title, okay, title and the specification. Number of variables, 3. We have 3 variables. Number of cases, 371, the sample size. And the data file, okay, we're gonna use EQS data file. Okay, this is the name of the data file. Matrix, raw matrix of the method, the maximum I can put estimation method. And the label part, so again, for EQS, we have to rename it. For example, V1 is ME, V2 is HE, V3 is math, because they are only allowed 3 types of variables, V, E here, and F and D. Okay. So then this is the model, equation part. This is our model. Again, 2 equations for mediation. V2, which is a home environment, V2 is predicted or regressed on V1 is star. Star means I'm going to estimate the coefficient of V1 here. V1 is ME, mother's education. So this is one parameter. This is one coefficient we would estimate. And then we have the residual part. And the V2, V3 is a math. Math is regressed on these 2 variables, V1 and V2. So I'm going to estimate the coefficient of V1 and also the coefficient of V2, okay? And we have the residual part. So that's a model. And the variances, V1, yeah, variance of ME, S1 parameter. E2, the variance of E2, okay? Variance of E3, all of these are variance. And then in EQS, you should use a statement of this, okay, effects equals yes to open the mediation effect. So I'm gonna print some options, okay, add option of effect, and it will just record the mediation effects for this. So this is the output. And we also have the information of the output. Okay, so the first equation, ME, which is V2, define V2 in EQS. The point estimated here, this is the coefficient for V1, and the standard error and Z value. And if we have the F sign, that means it's significant at the alpha level 0.05. And the math, which is defined in as V3 in EQS, and the coefficient of V2, coefficient of V1, and standard error, Z value, significant. Is significant of all of these 3 parameters. So actually, this is A. This is a coefficient A, and this is a coefficient B. Okay, this is a coefficient C prime. Okay, this is a C prime. This is a C prime. This is a B. This is A. Okay, all of these coefficients are reported here. And variance part. Variance for ME. That is a variance. Okay, that is a variance of ME. This is the standard error of the variance and the Z value. Variance of B2, the residual of the home environment, the standard error, Z value, significant. Variance of the residual mass, standard error, Z-value is significant, and we don't have F and D. We don't have the little variables part. Now we also have the effects equals yes. Okay, so let the EQS print out the mediation effects. So here, this is a mediation. Okay, math, the dependent variable V1 is mother's education. So mediation A times B is reported here, 0.065. And standard error is reported here, and the Z ratio. So it is significant, okay? There's an add sign, it is significant. So based on this part, you can answer that, yes, there's a significant mediation effect because this value is significant, okay? In times D is significant. Yeah. Any question for EQS? Any question? And also the code is provided in ELC. Also the data is provided in ELC.
How popular is EQS?
It's not popular as M+, yeah, but some of the results are more accurate than M+. Yeah,
Interesting.
yeah. Okay, so Amos, again, we don't have Amos installed in our computers, but if you have that one, it's also powerful. You don't need to write equations. Instead, you can just draw those tests are done here. So we have three variables, ME, HE, math. In order to add the residual part, you have to use, you have to use a symbol here. The symbol like this, here, just like a stamp. So you have to add this symbol on top of the HE to add a residual of the HE and the residual of math. Okay. And the right click the circle on top here, and you can set a lot of coefficient of weight or variance, something like that. So these are three paths, and we will also calculate the variance of three parts for you. So Amos, that's a model part, but how about mediation? There's no mediation reported here in this model. In order to look at the estimate of mediation, you have to open this analysis tab, and there's a checkbox. Okay, there's a called indirect, direct, and the total effects. You have to check this item, then you can see the mediation report. Okay. So go to view and analysis properties, it will automatically pops out a window. So you have to check this item, indirect, direct, and the total effects. And then the result table is reported here, okay? So total effect. So for the estimates, we have total effects, we have direct effect, we have indirect effect. So total effect, direct effect, indirect effect. But look at these tables, it just give you these numbers. There's no test. You don't know if it's significant or not. No simple test provided here. But of course, if you really want to see the standard errors and the p-values, you can run bootstrap. So there's another option for you to run a bootstrap estimation. So they will report the bootstrap standard errors, and you can see if it's significant or not. Okay. We just reported the numbers. Okay, so that's for Amos. Yeah, I think I have already covered all of this software. We talk about R, we talk about M+, EQS, Amos. Question? Formulation part? Question? Now, if you don't have any question, And yeah, you can do the exercise. Okay, you can use that lab in the rest part, or yeah, you can just go home if you don't want to do the exercise here. No question? Okay, yeah, then that's the base class.
So will you be giving back 3 and homework 3 and 4
Yeah,
next week?
so, okay, homework 4 is due today. And next week, I'm gonna give you all the graded homework 3 and 4, and then we're gonna explain the 2 homeworks. Yeah.
So we'll probably get homework 5 next week, right?
Maybe.
Well, I'm just thinking the timeline of what's left on the class,
Yeah, you're right.
you know,
Yeah, you're right. Yeah.
so.